We're going to take a look at some more complicated rational functions in their graphs. So the first thing, let's see, we have a graph of 1 over x, shifted 2 to the right and 3 down. Write an equation for the new graph. So 2 to the right would be 1 over x minus 2. And then down 3 minus 3. So the new asymptotes would be at x equals 2 and y equals negative 3. So for more complicated ones, meaning yesterday we just did 1 over x with shifts, and then we had ones with just an x in the numerator and denominator, we're going to look at ones today with higher powers in the numerator denominator. So here's our checklist. So when we're going to go through a problem and we're going to look at all of these. So the first thing we have to do is factor. So we have to box and circle these. So what multiplies to negative 6 and adds to 1? 3 and negative 2. So we have x and x plus 3 minus 2. And then we have this bottom one. So it multiplies to negative 6 and adds to 5. 6 and negative 1. So let's see, this top row would be 2x and x plus 3 minus 1. So factoring is done. Find the domain. We want to look in the denominator. So our domain, it can be all reals, except x cannot be negative 3, and x cannot be, well, let's see, because we got that negative 3 because that's when this equals 0. So when does 2x minus 1 equal 0? Well, when x is 1/2, so x cannot be 1/2. The next thing we're going to do is simplify. Well, we'll notice those reduce out. So we have x minus 2 over 2x minus 1. And then we're going to look at our wholes. And what a whole is it means on these graphs, you might look like this on a calculator, but that there's some tiny value where it doesn't exist. There's a little hole there. And our wholes are in the term, it's a 0 in the term that reduces out. So in this case, we have a whole at x equals negative 3. Now the next thing we're going to do is we're going to find the zeros in the y-intercepts. Well, this is our same function, and we can use our reduced down form. So we have x minus 2 over 2x minus 1. Well, let's see, our zeros, they're talking about our x-intercepts. So we know our x-intercepts are of the form x comma 0. So we can replace our y with 0, x minus 2 over 2x minus 1. Well, it only equals 0 when there's a 0 in the numerator, so whereas 0 equals x minus 2, so x equals 2. So we know there's a coordinate 2 and 0 on our graph. Our y-intercept, it's of the form 0 comma some y value. So let's see, y equals 0 minus 2, 2 times 0 minus 1. So our y value equals 2, so there's the coordinate 0, 2 on our graph. The next thing we do, it's the same one, we use our simplified form again. So we have x minus 2 over 2x minus 1. Our vertical ones, zeros in the denominator. So, well, what makes, where to go? What makes a 0 in the denominator? When does 2x minus 1 equal 0? Well, when x equals 1/2. So what that means is we have a vertical at 1/2. Now, slant and horizontal, we talked about this yesterday. briefly. So we might have a horizontal or we might have a slant, meaning it's at an angle. And we have to look at the degree, which is the highest power of the numerator and denominator. If the numerator degree is less than the denominator, it's a horizontal at y equals 0. If they equal each other, it's also a horizontal, but it's at y equals the leading coefficient over the leading coefficient. So an example of this, what if we had y equals x squared plus 3x over x to the fourth minus 2x. Our degree is less, so it's at y equals 0. If they're equal, for example, if we had 2x squared plus 3x over 4x squared plus 5, they're equal, so we take those leading coefficients, y equals 2/4. And the last one, if it's greater, it's going to be a slant one, and we have to do long division to find it. And we'll find this equation at the end that's of the form mx plus b. So if we need to find this one, well, let's see, here's our degree. So they're equal, so it's going to be at y equals our leading coefficient 1/2. So let's take a look at this one, determine all this stuff, and we're going to go through this whole list here, maybe even do more than this. Well, let's see, we can't factor, so let's see, what is our domain? Well, our domain is all reals, except we know x cannot be 2 because that would give us a 0. Well, it's simplified, so let's find our zeros. And again, this is of the form x, y is 0. So when does 0 equal 3x minus 1 over x minus 2? Well, that would be when 0 equals 3x minus 1, the numerator. So x equals 1/3. So we have the coordinate 1/3, 0. What about our y-intercept? Well, that's when we plug in 0 for x. So we have 3 times 0 minus 1, 0 minus 2. So y is at 1/2. There isn't any holes. And then those asymptotes, let's see, our vertical, that's where we look in the denominator. So x would equal 2. Our horizontal, let's see, the degrees are equal, so it's at y equals 3/1. So this last one we're going to do the same thing, except this one we can factor. So x minus 2, difference of squares. So it would reduce down to 1 over x plus 2. So to start with, we're going to take a look at everything. Our domain, well, we look at this factored form, so it's all reals, but x can't be 2, x can't be negative 2. A term reduced out, so there's a whole at x equals 2. Our x-intercept, so x comma 0, where does 0 equal 1 over x plus 2? Well, that's our numerator, so there isn't one. Our y-intercept, so 1 over 0 plus 2. So we have 0 and 1/2. Our vertical, we look in the denominator. So we have x equals negative 2. Horizontal, we look at the degree, and it's less, so then it's at y equals 0 because this one's 1 and this one's 2. All right, this last one we're going to do the same thing, and just for the sake of time, I'm going to factor this top one. So we have x minus 1 over 2x minus 1. So we won't have any holes because nothing reduces out. But our domain, all reals except x cannot be 2. Let's see our zeros. When does x comma 0? So when does 0 equal x minus 1, 2x minus 1? So it's when 0 equals the numerator. So there's 2 zeros at x equals 1 and x equals 1/2. So we know these coordinates are on the graph. Our y-intercept. So we know it's when, let's see, 0 minus 1, 2 times 0 minus 1, 0 minus 2. Let's see, negative 1 times 1, negative 1 over negative 2. Wait, that would be 1 over 2, negative 2. So y equals negative 1/2. Let's see, asymptotes. Vertical is pretty easy at x equals 2. But the horizontal, well, we'll notice the degree is higher, so this one is a slant. So we have to divide it out. X minus 2, 2x squared minus 3x plus 1. So x times what gives you 2x squared? Well, that's 2x. So we got 2x squared minus 4x. See, plus 4x, 1x, plus 1. So x times what gives you 1x? Well, that's 1. So you have 1x minus 2 plus 2. So we have a remainder of 3, but we're just concerned about this part. We don't care about our remainder. It's at 2x plus 1.